In the meantime, my name is Sebastian Kemsky. I'm a principal solutions architect here at AWS. I work with startups primarily in the Central and Eastern Europe, Poland, Czech Republic, Slovakia. But of course, as we are a global company, I have a pleasure of working with startups across whole Europe and the whole world. So what about my screen? Can you see it?
Yes, it's visible. So we have it.
All right, perfect. So I hope that you see my presentation maximized so we can proceed. So basically, my mission here is Mission Impossible. So I have just 30 minutes. I have to go through all the AI, ML, and data analytics services in AWS, which doesn't seem feasible. So it will be quite a roller coaster, but let's try to do our best. So let's split our journey into the two parts, because we in AWS treat AI, ML, and data analytics a little bit separately. When it comes to the machine learning and AI, of course, we do realize that we are in quite an early days when it comes to artificial intelligence. So these are still, I would say, some early tries, and sometimes it's really hard to call an artificial intelligence a real intelligence. But it doesn't mean that companies do not use the AI ML. We have more than 100,000 actual customers using AI ML services, which is really a lot. And as we just typically use the term machine learning, but it's not just one service. Just the last year, we have released more than 250 features, new capabilities, only for our AI ML platform, which is incredible. So this just can give you an impression of how quickly this thing develops. And when it comes to the customers, 100,000 of customers who actively use AI ML, these are very different companies. And some of those companies, their business domain is completely different. They just use AI ML to help their core domain. But also there are companies which start with the AI ML offering, and this is the core of their competencies. So they have very different needs. So they have also needs for the very different services, sometimes on a very different conceptual level. So this is important that when we as AWS shape our offering, that we should fit the needs of all of those kind of companies. That's why when it comes to AI ML, we don't have just one service, we have a full stack of services. And this full stack of services consists of three conceptual layers. And the bottom layer is, I would say, the low level of abstraction layer. So it's for all the experts who are actually building something completely new. For instance, they create new frameworks. They pretty much set the new standards, that they create the solutions that will be used by other companies tomorrow to build AI ML capabilities. So typically, these are just GPU-powered instances, super powerful instances, which are combined in ultra clusters. We offer AMIs, so the virtual machine images, which already, for instance, contain all kinds of solutions that can be used to build very powerful AI ML workloads. And the top layer is, I would say, some sort of cognitive services or AI in the box services, where you already have some pre-trained models created by someone who specializes in AI ML. And right now you just use them by, for instance, embedding them in your applications to actually get some sort of synergy. So to enhance the capabilities you already have and provide your own customer with something more powerful, more interesting, or more helpful. So let's start with the bottom layer. When it comes to this bottom layer, so the low-level kinds of services, we offer a lot of very different instances that you can run your AI ML processing on. And those instances are optimized for different purposes, because you optimize in a different way for inference and for training. In many cases, for training, you need very powerful GPI-powered instances, while for inference, for instance, for real-time inference, which doesn't have to happen that frequently, you don't need there's firepower, and sometimes it's good from the perspective of the cost performance or just cost efficiency. It's good to stick to something which is optimized in a way that helps you reduce those costs. So we have a wide selection of those services. Of course, we have partnerships with the major hardware provider. So for instance, a partnership with NVIDIA and Intel, but also we create our own chips like Graviton and Inferentia, which are optimized for certain kind of scenarios. Three interesting options that I would like to mention is P4D, which is the most powerful GPU-powered instance in the cloud right now. And you're probably aware of the shortage of the GPUs in general space. And in AWS, you can get those P4D super powerful instances. They are available. They are just out for you to use. Another interesting kind of instance which is optimized for the deep learning is our collaboration with Intel. It's EC2DL1. Like I said, it's optimized for the deep learning. It's also a very powerful kind of instance. And the third one I would like to mention is Inferentia. This one is very interesting because of two reasons. First of all, it was developed completely within AWS. And the second of all, it's optimized not for training, but for the inference. So it's not the typical kind of focus that was present before when it comes to the creating of hardware, which was dedicated to machine learning. Inferentia is a special kind of hardware, but it doesn't mean that you have to rewrite whatever you've already created. There is an SDK called Neuron, and if you already have used one of the most popular libraries like TensorFlow, MXNet, or PyTorch, you can just use this SDK to adopt your workloads and run them on Inferentia without rewriting your stuff, which is, I think, very, very helpful. We can move, let's say, in a fluent way to the middle layer, which is probably most interesting for the majority of the companies. And the middle layer is, I would say, some sort of a golden mean. So you don't have to have necessarily a high experience and a high level of specialty when it comes to the machine learning, but you already know what you would like to do. You maybe even know what kind of algorithms you would like to use, or at least what you would like to start with. And right now, you'd like to scale it somehow. You don't want to reinvent the wheel. You don't want to set up the basics. For instance, you would like someone to create the foundation for the MLOps pipeline in your enterprise, in your company. Probably you would like to have some tools, for instance, to debug your models or to assess the quality of your models. And you don't want to build all of this tooling from scratch because you would like to focus on your business problem. And that's where this middle layer really helps you. We have a solution which is named SageMaker, and basically right now it's integrated within one web-based IDE, which is called SageMaker Studio, and it provides you all of those options. So you can start with basic things like picking up algorithm. You can manually label some data, for instance, for supervised learning. You can trace your models. You can deploy them both for the real-time and batch inference. You can then fine-tune them, deploy, and of course manage them in time. And it's also integrated with the modern CI/CD, so you can version control your models. You can make a conscious decision about what is supposed to be deployed, when it's supposed to be deployed, and so on. So this is the one-stop shop for someone who would like to build the machine learning based solution in the cloud and is not happy with just package pre-created by someone else models. Like I said, it's a fully integrated IDE, so it's you don't have to configure all the components. It contains, for instance, the Jupyter notebook, so you can start by experimenting. You don't have to start with a fixed structure. You really can start by learning things and learning how things work out for you. You don't have to worry about the infrastructure because, for instance, for the Jupyter notebooks, it will be automatically set up for you. You will just give the major, I would say, key parameters, key configuration expectations, and this will be set up for you automatically. When it comes to all capabilities of SageMaker, it would take probably 2 hours to go just briefly, but I think that you can basically split them into 4 categories. So prepare the data for your machine learning, build your model, then train and tune them, and in the end, deploy and manage. So for instance, keep an eye on the quality of the model, whether they corrode or not. And in this case, all of those features are pretty much optional. So for instance, you can use feature store to mix your models sometime in time. You can use a data wrangler to prepare your data. But you also can do it manually outside of the SageMaker if, for instance, you already have something, or if for some reason you would like to not use the data wrangler. Some of the interesting capabilities that are inside SageMaker are, for instance, pipelines, when you can compose the workflow of all your steps that are within your machine learning flow. Another interesting capability is Autopilot, which is pretty much an AI bound by AWS, which helps you to pick the correct algorithm to fix your problem just based on the data you put in. So it's some sort of an immersive solution when the actually AI, it helps you to build AI solution. So we have very interesting capabilities like this. All righty. So let's move through to the top layer. And like I said, these are cognitive services which are fully packaged, and each of them is very, very different. Of course, they can be aggregated in some sort of categories that you can see right now on the screen. So we have solutions which are, for instance, focused on the speech. So you can both transcribe the spoken language, and you can also generate the spoken language base of the text. There's a recognition from the visual images. There's a chat functionality also. Of course, there's various services to work with the texts. Also, we have solutions which are dedicated, AI-powered solutions which are dedicated for industrial kind of purposes that I will cover just in a minute. And if you are concerned about highly regulated environments, like for instance, all kind of medtechs and in the general healthcare, we have also some variants of the services which are optimized and which have a certain level of compliance exactly for this kind of application. So I have just a few examples because it's not possible to go through all of those solutions. I will start with Kendra, which is very interesting because it's an equivalent of an enterprise search, but this enterprise search works on NLP. So it's really it's able to actually understand the natural language, and it's able to interpret it and use it to, for instance, retrieve the results. It's good not only when you try to integrate it in bot style of solutions, but it can also replace in certain cases your enterprise search based on more typical solution, more typical indexes. Another interesting solution is a contact lens. So it's some sort of an AI that helps you to optimize a service named Amazon Connect as a more traditional service, which is some sort of a call center in the cloud or call center as a service. So this one, based on the actual behavior, based on the history of interactions, help you to optimize the work of your call center at scale. Amazon Fraud Detector is quite a flexible solution that runs in the fintech space. It helps you to analyze the transactions, financial transactions, and detect ones which are suspicious. And of course, as fintech doesn't mean that there's just one scenario. Those scenarios can vary a lot, especially across the geographies, across the type of industry. So you are able to build your own financial models which are optimized for your own scenario here. Another interesting scenario, which is like out of the completely different planet, is Code Guru and DevOps Guru. And this one is trained based on the repositories of code. And it's supposed to create some sort of code review as a service, which is, of course, also powered by AI/ML, and helps you to provide automated guidance for all the developers regarding how they meet the certain conventions, good practices when it comes to creating code, but not only on the syntactical level, but also when it comes to, for instance, architectural capabilities of what they create, like availability and performance. I already mentioned the DevOps Guru. This is a newer, let's say, the version of the service. It started with just the Code Guru. The DevOps Guru was a new addition, and this one is more focused on the architectural capabilities. Another interesting cognitive service that, like I said, is a higher level concept service is Amazon Personalize. And this one was created based on our experiences on creating a huge e-commerce site named Amazon.com. So we are able to build our own personalization engine. And right now we've packaged this personalization engine for you so you can use it in your solution, in your kind of business. You can train your own model. model, you can collect your own interactions, and you can assess those interactions based on whether they are positive, neutral, and it's up to you basically how you use it. The common denominator is that it's supposed to deliver the personalized experience for your end user, for the end user of your platform. I also mentioned a separate category of the AI-based solutions, which are aimed for the all kinds of industrial solutions. They are very, very different, and they start with solutions like Panorama, which are actually based on the hardware solution, which is plugged to your on-site cameras in your site. But also there is a family of services named Lookout, which is, I would say, more on the software side. They are able to analyze various kinds of input, for instance, metrics or the input from the visual cameras. And their main purpose is to look for all kinds of anomalies. So they are able to save you a lot of money by detecting the actual failure before it really happens, which may be very important, especially in those industrial scenarios when the actual hardware, when the actual equipment can be very, very expensive. I've also already mentioned this particular set of services which are aimed to help all kind of med techs. So, for instance, Health Lake is a dedicated kind of our data lake, but dedicated especially for the medical industry. The same applies for the Comprehend Medical and Transcribe Medical. So these are more sophisticated versions of those services which are optimized exactly and trained with the models which were intended and designed exactly for being run in this medical space. All right, so this was a part of our very, very quick, very, very fast journey, which was dedicated to the AI/ML. Let's turn our focus to the actual data analytics. So all kind of data processing, which helps you get insights out of huge volumes of data or the fast streams of data which go through the systems of our enterprise. When it comes to the modern data architectures of 2021, we already can enumerate some components. So for instance, there is a need for ingestion, a lot of data, which doesn't necessarily have to be structured, which typically requires data schema on read, not on write. So we have to be flexible because sometimes these data span different boundaries of the system, boundaries of the storage, even boundaries of the parts of our organization. But still, to get valuable insight, we have to cross those boundaries and get our insights from the collective volume of this data. So this means that typically the essence of our modern data analytics solution is the data lake when we aggregate this data. But still, aggregation is not everything. Of course, we need some the inputs of this data. So we need the relational databases and non-relational databases, which actually are this input. We need the machine learning, which was already mentioned, to also help create additional insight based on the machine learning models. For the fast data analytics or for the general analytical processing, we typically need some sort of data warehousing because it's not possible to do the analytics on completely unstructured data, especially on completely unbound volumes. Also, we need the dedicated solution for distributed processing of data, which is here named big data processing. So basically modern data analytics involves very different kinds of technologies. And the key point is that those technologies are not completely independent. They all mix, that all integrate, they all co-use certain data or certain elements. And the good news is that AWS provides solutions in all of those spaces. And typically it's not just one solution, but it's a set of solutions that you can tailor to your particular needs. And in this particular case, we can, of course, start with I would say, the essence of the modern data analytics, which is typically a data lake. In AWS, the data lake is based on one of our oldest services, probably even the oldest one, which is Amazon S3. Amazon S3 is basically an object storage, completely unbound object storage. And it's right now, in fact, it's the most popular choice for data lakes worldwide because of how polished it is, because of its durability and its scalability, that it can scale pretty much indefinitely. So in case of our data analytics on AWS, basically this is the bloodstream that data goes through S3, and all kinds of services that use this data can reach out to S3 when it comes to the input of data, but also when it comes to putting somewhere the already processed data. There are plenty of companies which are running their data lakes already on S3, and but data analytics is not just S3, but you need all those purpose-built data services which deal with particular concerns, would deal with particular capabilities to be covered. The first one is, and probably a very interesting one, because it's very, very closely attached to S3, but not only, is Amazon Athena. And Athena is basically a query engine. So having the data in S3, having unrestricted, unbound data that doesn't impose a strict format is not enough. You have to actually figure out what's in this data. You have to work with this interactively. You have to be able to filter this data and to do some basic processing on that. And Athena is super flexible because it helps you not only to impose some sort of schema on read structure, but it also helps you to mix the data in S3 with the data in all other kinds of relational and non-relational sources. So it's basically the engine which helps you to connect the data regardless of where it resides, connect it with S3, and then figure out the insight from all this accumulated data. Of course, sometimes this is not enough. So making a query using this distributed query engine is not enough. You need some sort of big data processing engine. And here we propose the service which is called Amazon AMR. The name may be new for you, but basically what's inside is the whole Hadoop ecosystem. So all kinds of popular Apache Foundation projects like Spark Streaming, Hadoop, Hive, Presto, or HBase, they are present here. And EMR is pretty much some sort of a wrapper which helps you to provision them automatically according to your requirements, according to the scale that you demand, and to run this processing on the data that you already have in S3 or that you ingest into EMR cluster. So this is a solution which helps you to wrap the complexity of Hadoop ecosystem, which is not trivial by itself, and just focus on what you want to implement on the top of that. There is also an option to use EMR not only on the typical Intel-based infrastructure, but also on ARM powered instances that are optimized for this kind of processing. Another pillar of the modern data analytics solution is an open search. An open search is an enterprise search solution. You may know it from the past as Elasticsearch service. It's based on ELK stack, and its main purpose is not only to aggregate logs or to search through logs, but it's all kinds of search. So you are pretty much able to create the search indexes, host them in the cloud, manage them in the cloud, and even visualized them using the dashboard software like, for instance, Kibana. Another kind of pillar which we have in our data analytics stack is about the ingestion of this and processing of the stream data. And we have various options there here. One of them is MSK, which is basically the managed Kafka. So nearly everyone knows Kafka. It's a distributed transaction log. Some treat it as a queue equivalent. I think that this is an oversimplification. I think that the good approximation is that this is not really a database, but this is a way of keep the streams while treating the time aspect, so the aspect of inflow of data as the first level citizen in how you store this data and how you process this data. So in AWS, you can manage the MSK, you can manage the Kafka cluster in an automated way. You don't have to configure, set up, or update it manually. This is all done for you in a completely managed way, especially with the recent addition, which is called MSK Connect, which is basically a managed Kafka Connect. So the very simple way to ingest data into your Kafka. Kafka is not the only option. We also have a service which is named Kinesis. It works in a similar way. It helps you to ingest data in a streamed way into AWS. However, also it has some very interesting additional capabilities because first of all, it's completely serverless. So it's really easy to scale it out. And the other thing is that you can actually put a sophisticated processing in the middle of stream processing. So you can host your own Kafka cluster, Flink cluster, sorry. Of course, also in a fully managed way, so you don't have to worry about the provisioning, and you can have your Flink processing on those streams of data to, for instance, provide real-time analytics capability to your business, which is a super powerful thing. Because the important thing is that to be able to deal not only with the big data, but also with the fast data. Another key component of our data analytics stack is Redshift, and Redshift basically is a compromise between between the analytical database and the data warehouse. So it's a columnar data warehouse, which of a very sophisticated architecture when your actual compute layer is completely decoupled from the storage layer, and it's additionally possible to put some layers in between, for instance, for the sake of the caching and boosting the performance even more. This is called Aqua. Amazon Redshift is built on the top of the open source product as well, because its primary foundation was a long time ago was the Postgres database. But right now it's the fully scalable, highly performant data warehouse analytical database in the cloud. To be honest, it's not just a typical database. It's extended with several additional capabilities. So, for instance, you can mix in your machine learning into the queries, into actual SQL, which is being run on this data warehouse. You can also use Redshift Spectrum to have your query spanning across several databases, not just necessarily your Redshift, but also some other SQL compliant databases, or using the Federated queries even as free. So there are several very interesting capabilities when it comes to Redshift. It's very actively developed. I think that right now it's the second most successful product in the history of AWS. The good thing is that between all those services, of course, data flows between all those services, and we have a service which really helps to orchestrate this flow, which really helps to manage this flow and to keep it into some, let's say, under control and into some boundaries. And this service is called AWS Glue. Its purpose is basically ETL, ELT, so extract, transform, and load, or extract, load, and transform. Typically, you start small and you start with some basic scripts which do that for you. But AWS Glue is very approachable. It's very comprehensive. It's very visual, and it provides you a lot of automations and a lot of functionalities that can speed up the development of your ETL processing. The thing is that we provide the service which is called a Glue Studio, where you can visualize your workflows, when you can create the standard steps, so you don't have to create code for all of those steps. You can also here monitor all those steps, everything visually. But in the end, of course, this is the code. So if you prefer to work with the code directly, this is also possible. The visual layer, the studio layer, is just to help you, especially visualize the more complex flows. There's a very interesting addition to the Glue Studio, which is called Glue Data Brew, and this is all about data preparation, data cleansing, and the management of the master data. So here you have more than 250 formulas and transformations which help you, for instance, to clear the data which may have some flaws. For instance, there may be some gaps in the data, or there may be some repetitions, and those pre-built automations and transformations can help help you create the pipeline which cleanses your data and really speeds up this part, which is this mundane and very tedious part, which is about data preparation, and which can sometimes consume even up to 80% of time that you spend on building the full data processing on your platform. There is a list of very impressive capabilities which are also in Glue, like for instance, elastic views, when the view on data perspective on a data structure spans across several sources. Because Glue is not just the ETL tool, it can also provide you an opportunity to create your own data catalog. So for structured data, when you have the schema on read approach, you can keep those schemas in a centralized way. So you don't have to redefine them all the time in every endpoint of your code when you do the data processing. I think that this is really an very underestimated capability, but it's very, very helpful, especially when your company grows very, very quickly. Yeah, all of those technologies, of course, we have this ETL, we have this Glue, but the point is that all of those technologies are, as they were created by AWS, they are optimized for interfacing. So for instance, if you want to load data into S3, from S3 to Redshift, you don't have to, and especially when it's a lot of data, you don't have to create your own solution to optimize it, to parallelize it, and so on. Those tools are already set there. They are already there. All the most popular formats, data exchange formats, which are already optimized for the columnar processing, they are also there. So the good thing is that while building a fully fledged data analytics solution on AWS, you have all the building blocks already in place. All you have to focus on is your feature, is your competitive edge, is the new value, the additional value that you would like to provide to your customer. You don't have to worry about the generic stuff, the mundane stuff, which is already there for you. I've already mentioned the federated query. So if you even load data into Redshift, it doesn't mean that you are limited only to data in Redshift. It's possible to mix several data sources even within one query, and then, for instance, mix it with calling the machine learning inference model in real time and have just one query which returns you the completely full and rich record of whatever is important in your processing. So it sounds like a lot of building blocks. It sounds like a lot of moving pieces, and you have to make them work and collaborate together, which is not always simple. But in this case, we have an additional service, a meta service, which is called Lake Formation, and you can use it pretty much to govern the whole data lake built on AWS, to set one structure for this, to set a common set of, for instance, access rights, and so on. So this is the best way to set up the new data lake in an organized way, in a way that doesn't even require you to set up all those services in separation. This way, you can build your data lake, including the actual ingestion, literally in days, which is a really nice capability, keeping in mind how complex it can get and how big volumes we are speaking about, right? And when it comes to all those services, it's not that you have just an option of using them, but even if you use them, there's still a lot of flexibility on how you use them. For instance, imagine all those big data Hadoop-based clusters in EMR. There are plenty of options on how to deploy them. You can have volatile cluster which are, for instance, active there only during the time of processing, so you can save time in the time when they will be potentially not active. So we have all those options. All of those services are very integrated. For instance, even the IAML capabilities, you can deploy your inference on EKS clusters, on ECS clusters. You can utilize the auto-scaling options of this infrastructure to make sure that you haven't just built the good AIML-based solution, but you have also done it in a very cost-effective way. On the top of that, we also have tools to visualize the effects of your work. So there's a tool named QuickSight, which is a BI tool which helps you to create visualizations, dashboard perspectives, and, for instance, embed them in the application of your choice. So, for instance, in the web interface, in the mobile interface, it have a very flexible cost model. And additionally, it has an additional solution which is called Spice, which helps you to contain some of this data in memory for a very fast access, so you can have your OLAP cubes directly within the memory of this BI tool, which speeds up the actual visualization even more. Of course, as we are speaking about AWS-based solution, it also has its own ML capabilities built in. So for instance, even directly in your QuickSight, in your BI tool, you are able to detect automatically the anomalies without using a dedicated anomaly detection solution, which is, I think, quite nice. A QuickSight queue has got a very new, interesting addition, which is right now available as a preview. And this addition is all about not creating the visualization by yourself, but it's about the tool creating the visualization for you based on the business language expressed question that you express. So you just, for instance, ask using the natural English language about the sales results in a context of segment within this and this period of time, and QuickSight Queues is able to create the visualization for you automatically based on the AI ML, which is a model which is created for you within this tool. I've already mentioned that Redshift is not just an analytical database or data warehouse, but also it's able to directly cooperate with your ML models, which is super powerful. And then those AI ML models are available directly from your SQL command line, so directly within your queries. So you don't have to mix those approaches somehow. They are pretty much mixed already by design. All right, this was quite a roller coaster, to be honest. I hope that this was informative for you. If you have any questions regarding any of those services, I will be very happy to answer those. Please feel free to register to EMEA Startup Loft slots, the open hours Mark has already mentioned. I hope all the links will be present in the materials, which will be shared after this presentation. In case of any trouble reaching me, feel free to find me on LinkedIn or on Twitter, and I will be happy to connect with you. Thank you very much.
Thank you, Sebastian. That was really a roller coaster, but I knew that you will be able to do that. So there are a few questions which I noticed. The first one comes from Ron Tamerin. The question is about the special EC2 instances for ML. Are they available also as on demand, meaning that I pay only for storage plus running time, but when I shut it down, there are no costs besides storage?
When it comes to all those instances, I think that they share pretty much the same model as any other kind of instance. I think there was you have to check the details on our page, aws.amazon.com, on the particular type of instance page. Because, for instance, I know that there were some particular rules for the Mac instances and for the billing of the Windows instances. So they can be some additional clauses there, but it really depends on the type of instance.
Okay, so please take a look on the calculator. There will be strict rules explained.
If there's anything specific, they will be described. This will be described on the sub page, which is dedicated for this family of instances.
There is another question for. I hope that I will say that properly. Faikal Arbai. We only use SageMaker for GPU-powered notebooks, so it's for dev, not production. Can we claim we use SageMaker for our product? I'm not sure if this is clear enough.
I'm not sure I understand. Well, if you already use it in a notebook, it's quite easy to productionalize it. So, for instance, you can take the logic that you already have in the notebook, and you can create a pipeline out of it. And then you can run this pipeline, for instance, using the SDK, or if even better, if you want to have a full CI/CD, full let's say MLOps pipeline, then you can put it in an entity which is called SageMaker project, and the SageMaker project is easily integrated with CI/CD. So if you've started in just a notebook, it's absolutely possible to turn it into fully automated infra as a code and a versionable code kind of solution. If this is what you meant.
I don't see that person is still with us, so there is impossible to ask for the clarification for the question.
Faisal has dropped. I see that he's dropped 5 minutes ago.
Robert is okay. Robert just mentioned that he is leaving. So can we run OpenSearch in VPCs? We don't want to expose the endpoints as a data privacy issues.
Yeah, I think so. Why not?
Cool. Okay. Any more questions? You can ask them directly, not only through chat. Please don't hesitate. Don't be shy. Switch on your video, switch on your microphone, and ask us. I don't see any hands raised. I hope that all the rules are clear for the challenge. So I strongly believe that that will be another one very successful program and beneficial for you. Any case, anytime, ask Konrad, reach Sebastian through office hours, and let us know if we can help you anyway. I just a moment ago I made my round to approve all the credits requests, so that's a part of the answer for Dennis. Dennis asked me directly in the email when that credits will be approved. So if you sent us during, for example, last week a request for the credits, now they are approved from my side, and we need, let's say, 2-3 days to process that in the systems, just to let these credits be on your account. So there is more than sure that they will land still in September to cover your September costs. Okay. Konrad put it in the IM also his email address. Please write your queries, questions, comments, feedbacks there. So, gentlemen, I'm talking to Sebastian and Konrad. Thank you for your involvement. Thank you for being with us. Thank you for a really great presentation. As I said, roller coaster, but very informative. All the participants, ladies and gentlemen, thank you for being with us. Now we are closing the call. So fingers crossed for you. And I hope that in the November I will meet with you on the pitch session. Thank you. Bye.
Brilliant. Thank you very much. Can't wait until I will see the effects of your work.
Yes, thank you, Marek. Thank you, Sebastian, for making so great explanations and introductions. And let's keep working.
Bye.
Bye.